Okay, so I'm going to do a little video demonstration in case this simulation is not working on your computer. So first, what I've got here is a coil of wire hooked up to a light bulb, and then I've got a bar magnet. Now, right now, these little compass needles are showing the magnetic field lines that are emanating out of the different poles of this permanent magnet. And so one thing we want to see is that these little dots represent electrons inside of the coil of wire. And we want to see what happens when we move a permanent magnet past or inside of a coil of wire. So you can see as I move it to the right and as I move it to the left, you should see that electrons are moving. Now I want you to pay close attention and see if there's what happens when I move it to the right versus what happens when I move it to the left. Okay, if you need to rewatch it to answer the question, you can slow it down, play it in slow motion, and see is there a difference when you move it to the right and to the left. Also, notice that when the electrons are moving, it should be fairly obvious what happens to the light bulb. And pay attention, does the direction of electron motion or magnet motion seem to have any impact on the kind of light that comes out of the light bulb? Now, if we go down here, we can add loops. So I've added an additional loop to the coils of wire. Let's see if that has any impact on the light bulb. I'm doing the same kind of motion with the magnet, and I want you to notice if there's any difference in the light bulb. So I'm going to go back down to 2 loops. I can even go down to 1 loop, and hopefully there's a pretty clear relationship between the number of loops and the type of light that is produced. You can also then adjust the magnetic strength, the strength of the bar magnet, and you should see a clear impact of that change on the light that's being produced. Okay, now we're going to go up here and we're going to click on the generator tab. Okay, when we turn on the flow of water, the water is now pouring. This is a wheel, so it's like a water wheel. The flow of water out of this tap is causing the wheel to move. So we're taking this potential energy from the water falling, and then it's kinetic energy, and that's turning into kinetic energy in the spinning wheel, the spinning magnet. And that is therefore somehow creating this electrical energy. You can see that the spinning magnet seems to be causing electrons to move. Now, again, pay attention. What happens when the North Pole goes by? And then what happens when the South Pole goes by? What's happening to those blue dots? What's happening to the electrons as the different poles of the magnets pass by? Now, if I take the flow of water and I increase it, faster water flow is going to create faster spinning of the wheel. And you should be able to clearly see what is that doing to the light bulb. What does that do to the electrons, and what does that do to the light bulb? Now, if I want to switch, instead of a light bulb, I can look at a voltmeter. This is a device that measures voltage. And what happens to the voltage as the magnet spins? See if you can describe that in words. I can see the needle here. I want you to see what you think is happening now if I adjust the flow of water back down. How does that affect the needle and the swinging back and forth? And then when I make it faster, you can see the effect on the needle. And if we go back to the light bulb, you can see the relationship maybe between how the voltage is being affected and how the brightness of the bulb is being affected. So that is what we wanted you to walk through in the simulation. So hopefully this video has covered the same content and you can now answer the same questions in the document about electromagnetic induction.